Intelligent Manufacturing Research Center, NCKU. Intelligent Additive Manufacturing Architecture, IAMA. Additive manufacturing, AM, can be applied to produce customized single workpiece in aerospace industry, medical devices, and parts of high geometrical complexity which cannot be easily produced by conventional means of manufacturing. The laser powder bed fusion, LPBF, process in particular can manufacture complex, accurate, and fully dense objects. However, there are still lots of remaining challenges of LPBF production quality. For example, how to efficiently find the optimal process parameters and how to effectively and timely evaluate the quality. The Intelligent Manufacturing Research Center, IMRC, of NCKU is dedicated to assist various manufacturing industries to accomplish zero-defect manufacturing. In other words, to achieve the goal of nearly zero defects of all products. Hence, we launched out our latest product on additive manufacturing industry, Intelligent Additive Manufacturing Architecture, which includes ISM, AVM, AM Simulator and Intelligent Compensator. IAMA offers a closed-loop, layer-to-layer control of the LPBF process through the in-situ metrology services formed by coaxial optical system equipped with thermocouple and high-speed camera, the application of automatic virtual metrology, AVM, and the simulation performed by AM Simulator along with Intelligent Compensator. The IAMA can realize both offline simulations along with real-time online monitoring and quality prediction. The two major functions of IAMA are in-time powder recoating and laser polishing to reduce the quality variation of each layer, so as to achieve the goal of nearly zero defect of the final product. The process status can be accessed remotely by Web GUI. The predicted homogeneity and roughness value and the melt pool images are displayed here in clear layout. The demonstration shows how the IAMA works on Tongtai, our industry partner's AMP160. The LPBF process starts from powder coating. In most cases, the powder should be homogeneously coated on the build plate. After coating, IAMA will then calculate the homogeneity of each layer and decide if recoating is required in 3 seconds to assure the quality of each layer before proceeding to laser printing. In laser printing stage, IAMA will monitor the status of the melt pool and homogeneity to calculate the surface roughness after printing and make decision within 3 seconds to decide if an extra laser polishing is necessary. The parameters such as laser power and laser speed are suggested by AM Simulator to compensate the insufficient parts done by the first laser printing. If the powder was not homogeneously coated on the build plate, the recoating process will be initiated to stabilize the quality of this layer. In the conventional method, the process sequence is coating and then laser printing right away without assessment in between. With IAMA, we can calculate the homogeneity of each layer in time before laser printing so as to ensure consistent quality of each layer. Then the ISM services and AVM work together to predict the surface roughness of each layer and then send commands to the controller to in time compensate, which effectively controls the surface roughness. The three benefits of IAMA are offline simulation, online quality prediction and layer-to-layer control. Offline simulation significantly improves the efficiency for finding viable parameters by 6.4 times via shortening the initial trial period by offline simulation. Moreover, online quality prediction can predict the quality of each layer in 3 seconds with AVM. Most importantly, layer-to-layer control is the core element to reduce the quality variation of each layer by 50%, which ensures the stability of production. All the innovative technologies integrated together accomplish IAMA, and realize the goal of nearly zero defects of Industry 4.1. With the implementation of IAMA, we can ensure the final product is in high quality. It is a definite game changer for the AM industry. Find more information at IMRC website.